Hi everybody. Today we're going to look at finding limits of rational functions algebraically. We're going to limit this discussion to rational functions where the top and bottom, the numerator and the denominator of the function are both polynomials. We're specifically going to look at limits as x approaches infinity. From our talk about sequences, I'm hoping you know that if f of x equals 1 over x, that the limit as x goes to infinity on f of x is equal to 0, because as the denominator gets bigger and bigger, 1 divided by a gigantic number is equal to 0. Similarly, the limit as x goes to negative infinity on f of x is also 0. So let's look at a couple others. Remember, here we're also looking at a domain of all real numbers that work in the problem, instead of just sequences when we were dealing with whole numbers. So let's take a look at g of x now. Again, if we want to see what happens as x approaches infinity, we can kind of look at some values first. I know that g of 100 is going to be 101 divided by 100. I know that g of 7,456 is going to be 7,457 divided by 7,456. And I'm hoping it's pretty obvious that the limit as x goes to infinity on g of x is equal to 1, and the limit as x goes to infinity, negative infinity on g of x is also equal to 1. When we get into other things, though, it's a little bit harder to see. For example, h of x, we could continue to plug in bigger and bigger numbers and see what value we get closer and closer to, but there's another way to deal with this. So I would like to suggest, one of the issues is, as x gets bigger and bigger, the numerator goes to infinity and the denominator goes to infinity, and that we really don't have a good way of dealing with all by itself. It would be really nice if the numerator went to a number and the denominator went to infinity, because then we have something similar like 1 over x. Or if the denominator was a number and the numerator was some value with x, then that would head off to infinity. So we want to see if we can rearrange this problem to look like that. So let's start by multiplying the top and bottom by the reciprocal of the largest power in the denominator, and that would be 1 over x squared divided by 1 over x squared. And essentially what this is going to do is make sure that our denominator is a number of some kind or other, and that way we can calculate the limit a little bit more easily. So let's see, if I multiply everything through by 1 over x squared, I'm going to get x times 1 over x squared, which is 1 over x, minus 4 times 1 over x squared, which is minus 4 over x squared, divided by x squared times 1 over x squared is going to be 1, minus x times 1 over x squared is minus 1 over x, minus 12 times 1 over x squared is minus 12 over x squared. And I'm hoping that you can see that as x goes to infinity, that this guy goes to 0, this goes to 0, that goes to 0, that goes to 0. So the limit as x goes to infinity on h of x is equal to 0 over 1, which is just 0. We can do a similar thing with k of x here. Multiply top and bottom by 1 over x squared, 1 over x. Again, we want the highest power in the denominator. So I'm going to multiply top and bottom by 1 over x. And so I'm going to get 7 divided by x minus 3x all over 1 plus 7 over x. And here again, as x goes to infinity, this goes to 0, and that goes to 0. And so we can say that the limit as x goes to infinity on h of x is the same as the limit as x goes to infinity on negative 3x over 1. And so that's going to give us negative infinity, because we're doing negative 3 times a really big number. And the limit as x goes to negative infinity on negative 3x over 1 is going to be positive infinity, because a really big negative number times negative 3 is going to be a positive number, divided by 1 is still a really big positive number. And finally, let's look at j of x. We can do the same thing. We can actually also just compare these leading coefficients. You notice the numerator is not growing as fast as the denominator. So I also know that the limit as x goes to infinity on, sorry, we're not doing vectors now, DeCrane. The limit as x goes to infinity on j of x is going to be 0.